Next distribution, uniform or rectangular distribution. The PDF of uniform or rectangular distribution is f of x is equal to 1 by b minus a, where a less than x less than b. Otherwise, the value of the PDF is 0. So the diagram of this function is like this. Between a to b, the function value is 1 by b minus a. The graph is only in between a to b. So here to the left side of b and to the right side of b there is no graph. No graph means that our function value is 0. Now, see what about mean variance of uniform distribution. So now first one, mean. So since it is a uniform distribution is continuous distribution, to find mean or average value, we have to apply this formula is equal to integral x into f of x dx. So here limits are here between a to b only. The function has 1 by b minus a. Otherwise it is 0. So a to b x into f of x. So integral a to b x into f of x. F of x is 1 by b minus a into dx. So if you simplify this one, that will give a plus b by 2. Integrate that one, you get a plus b by 2. That is the mean value or average of uniform distribution. Next, variance given by, we know that here mean is expectation of x. Variance is expectation of x square minus expectation of x whole square. That is equal to again integral a to b x square into f of x dx minus mean whole square. Already we found mean value. Mean is a plus b by 2 whole square. So here replace f of x with our function is 1 by b minus a. 1 by b minus a. Simplify that one. So that will give b minus a whole square by 12 finally. That will give b minus a whole square by 12. There is a variance of uniform distribution. Similarly, what about standard deviation? Standard deviation is square root of variance. So square root of b minus a whole square by 12. That is equal to b minus a by under root 12. So that will give a standard deviation of uniform distribution. Now next we'll discuss about exponential distribution. The PDF of exponential distribution is f of x is equal to lambda into e power minus lambda x, where lambda greater than or equal to 0 otherwise. Now, the importance of exponential distribution. So the importance of exponential distribution is good for modeling duration of events. See, I am giving examples here. The lifetime of an electronic device, the time between arrivals of 2 successive buses, the duration time of a car service, the time until next earthquake occurs, and so on. Like that, it is good for modeling duration of events. See here to find a mean. Similarly, here also mean and finding mean of exponential distribution by applying that formula. Mean is given by integral of x into f of x dx. So here it is defined, our function is defined for greater than or equal to lambda greater than or equal to 0. So we get integral 0 to infinity x into e power 0 to infinity x into lambda into e power minus lambda x into dx. Evaluate that integral, will get mean as 1 by lambda. Similarly, finding variance, mean is expectation of x. Next, variance. So we know that variance is given by expectation of x square minus expectation of x whole square. So applying this formula, integral 0 to infinity x square into f of x. Our function PDF is lambda into e power minus lambda x into dx minus mean whole square. Mean is 1 by lambda whole square. So simplify this one, that will be finally 1 by lambda square. 1 by lambda square. That derivation is not required. Simply it is better to remember direct results here. Mean value 1 by lambda, variance value 1 by lambda square. So mean is 1 by lambda, variance is 1 by lambda square. Here what about standard deviation? Standard deviation we get a square root of positive square root of variance, that is a 1 by lambda we get. Standard deviation 1 by lambda. Whereas in case of uniform distribution, we got mean as mean value, mean or average, that is expression of x is a plus b by 2. Variance, this is a sigma square. Variance is, we got b minus a whole square by 12. The standard deviation, positive square root of variance. Now we will do problems on exponential distribution. First problem, the life of a bulb in hours is a random variable with an exponential distribution given as a PDF f of t is equal to alpha e power minus alpha t between t is 0 to infinity. The probability that its value lies between 100 and 200 hours is 100 and 200 hours is here the required probability here p of 100 less than that is t less than 200 is equal to integral 100 to 200, so that f of t into dt. So that will give the probability that its value lies between 100 and 200 hours. So 100 to 200, our f of t given as here alpha e power minus alpha t dt. So alpha is constant, put outside. E power minus alpha t integration is e power minus alpha t by minus alpha between the limits 100 to 200. Alpha will get cancelled. Put that minus outside. Upper limit of t is 200, lower limit of t is 100. So we get e power minus 200 alpha minus e power minus 100 alpha. So applying minus, we get e power minus 100 alpha minus e power minus 200 alpha. So that is the option is correct. So the probability that its value lie between 100 and 200 hours is e power minus 100 alpha minus e power minus 200 alpha. Now come to that second question. Assume that the duration in minutes of a telephone conversation follows exponential distribution. So this is given a corresponding PDF f of x 1 by 5 e power minus x by 5 for x greater than or equal to 0. The probability that the conversation will exceed 5 minutes. Means that find out p of x greater than 5 will exceed 5 minutes. Probability that telephone conversation will exceed 5 minutes is p of x greater than 5 means integral 5 to infinity. Upper limit will get infinite into corresponding function f of x into dx. So integral 5 to infinity f of x is 1 by 5 e power minus x by 5. So 1 by 5 constant, e power minus x by 5 integration is e power minus x by 5 by minus 1 by 5 between limits 5 to infinity. Here 1 by 5 will get cancelled. Put that minus outside. E power minus infinite value, upper limit of x is infinite. E power minus infinite value is 0 minus e power lower limit of x is 5. E power minus 5 by 5, that is e power minus 1 will get. That is equal to minus plus will get 1 by e. So that 1 by e, that is option A is correct answer. Now we will do problems on uniform distribution. Suppose First problem, suppose you break a stick of unit length at a point chosen uniformly at random, then the expected length of the shorter stick is. Suppose you break a stick of unit length at a point chosen uniformly at random. Uniformly at random means that apply uniform distribution. Then the expected length of the shorter stick is. Here, unit length, the given stick unit length, let us say the initial point 0, 1. So unit length chosen, then the expected length of shorter stick. So let us say this is the middle point here, we will get 1 by 2. To get the shorter stick, you have to break that stick at less than half. So here x indicates here, let us say length of stick. Then x is uniformly distributed between 0 and 1 by 2. Take only this. To get the we want shorter stick. Shorter stick means if you go for beyond 1 by 2, that will not be a shorter stick. You have to go for between 0 to 1 by 2 only. So if you break the stick between 0 to 1 by 2, then only you will get a shorter stick. So here x is uniformly distributed between 0 and 1 by 2. So let us say this is a A value, B value, A0, B1 by 2. The PDF of uniform distribution is given by 1 by B minus A. This is a 1 by B minus A means 1 by 2 minus 0. So we will get 2. So f of x is 2. Now, here expected length means that find out expected value, nothing but mean. Expected value or mean. So here x is a continuous random variable. So to find mean here, I will apply integral x into f of x dx. What about limits here? Limits will be here, lower limit a to b. A to b means 0 to 1 by 2. So integral 0 to 1 by 2 x into our function f of x, that is the PDF of uniform distribution, we got 2 into dx. So 2 into x square by 2 between 0 to 1 by 2. 2 will get cancelled. Upper limit 1 by 2, so we will get 1 by 4 minus 0, that is equal to 1 by 4. So the expected length of shorter stick is 1 by 4. This is regarding first problem. Now come to second question. X is uniformly distributed random variable that take values between 0 and 1. So uniformly distributed means that apply uniform distribution. So here given A0, B1. We know that PDF of uniform distribution is given by 1 by B minus A. So 1 by 1 minus 0, that is equal to 1. So PDF is 1. Now the value of E of x cube will be. So how to find that E of x cube value? Here E of x cube is given by integral limits are 0 to 1. 0 to 1 x cube into f of x dx. So integral 0 to 1 x cube into our f of x is 1. F of x is 1 dx. So x cube integration x power 4 by 4. So between 0 to 1, that is equal to, we get 1 by 4 answer. That is option C is correct. Next problem on uniform distribution. Let x1, x2, x3 be independent and identically distributed random variables with the uniform distribution. Uniform distribution on 0, 1, the probability of P of x1 plus x2 less than or equal to x3 is. Apply here uniform distribution. Here, let's find out P of x1 plus x2 less than or equal to x3. You can write this one as P of x1 plus x2 minus x3 less than or equal to 0. Now, so here x1, x2, x3 are independent and identically distributed random variables with uniform distribution. So here interval is given as 0, 1. So A value 0, B is equal to 1, the corresponding f of x, PDF of uniform distribution is 1 by b minus a. So we get 1 by 1 minus 0, that is equal to 1. Now, what is the E of x1? The mean or average or expectation of x1. So, what is the mean of uniform distribution? Mean of uniform distribution is a plus b by 2. That is equal to a value 0, b value 1. So, 0 plus 1 by 2, that is equal to 1 by 2. It implies E of x2 and E of x3 also 1 by 2, because all three are identically distributed, independent and identically distributed. So, E of x2 and E of x3 also 1 by 2. Similarly, what about variance of x1? Variance of that uniform distribution is given by formula b minus a whole square by 12. Variance of uniform distribution. So, here b is 1 minus 0 whole square by 12. So, we will get 1 by 12. So, it implies I can write v of x2 and v of x3 also 1 by 12, because all x1, x2, x3 independent and identically distributed. Identical means all values, variance values will be same, mean also same. So, now here let will take u is equal to x1 plus x2 minus x3. Let u is equal to x1 plus x2 minus x3. Now, find what about expectation of u. Expectation of u means expectation of x1 plus x2 minus x3. Using expectation properties, I can write expectation of x1 plus expectation of x2 minus expectation of x3. So, expectation of x1 is 1 by 2 here, 1 by 2 plus 1 by 2 minus 1 by 2, that is equal to 1 by 2. So, expected value of u is expected value of u or mean of u is 1 by 2. Now, finding variance of u also. Variance. So, variance of x1 plus x2 minus x3. Using variance properties, again this one has variance of x1 plus variance of x2 plus variance of x3. Here x1, x2, x3 are independent, identically distributed. We have the formula I have given variance of ax plus or minus by for only two variables. This is a square variance of x plus b square variance of y, where x, y are independent. We can extend this one for three variables, more than three also. So here we have three variables, x1, x2, x3. So we will get here, even though minus is there, we will get plus only here. So x and y are independent. Here x1, x2, x3 are independent. So again, v of x1, v of x2, v of x3. We know that v of x1 value is 1 by 12 plus 1 by 12 plus 1 by 12. That is equal to 3 by 12. That is equal to 1 by 4. So that is a variance of u. Now, here we have p of x1 plus x2 minus x3 less than or equal to 0. We have to find out this value, and we are taking this one as u. So, u, see, now for u0, what is the corresponding z value? I am converting into normal distribution. For u0, corresponding z is equal to, what is the formula, general formula, z is equal to x minus, it is a standard normal variable, x minus mu by sigma. Here our x is u here. So, u minus mu. What is the mean here? Mean of, already we found the mean of u. Mean of u is 1 by 2. So, 1 by 2. So, I am taking u0 here. u0 minus 1 by 2 by sigma. What is the sigma? Means standard deviation of u. So, we got here variance of u is 1 by 4. It implies standard deviation is a positive square root of variance, will get 1 by 2. So, we will get here 1 by 2. So, for u0, the corresponding z value is 0 minus 1 by 2 by 1 by 2. This 1 by 2 is the mean of that u. This 1 by 2 is that standard deviation of u. So, we will get this value is minus 1. Therefore, from this one I can write p of u less than or equal to 0 is same as p of z less than or equal to -1. So for u0 we got z value -1. Therefore, which is equivalent to p of z less than or equal to -1. What is this area? P of z less than or equal to -1. Here, this is the z0 here. Symmetrical about that normal curve is symmetrical about z0 line. Less than or equal to -1 means we'll get -1 here. That is equal to -1. So less than or equal to -1 means we require this area. So this area is same as, suppose if you take here z is equal to 1 will be here approximately here. So both areas are same. Area from -1 to minus infinity is same as area from 1 to infinity. So that is equal to, I can write P of z, P of z greater than or equal to 1. Area from -1 to minus infinity is same as area from 1 to infinity. Both are equal. So what about this area? So to find this area, I can write like this: P of 0 less than z less than infinity minus P of 0 less than z less than 1. So area from, so I'm taking here subtracting 0 to 1 area from 0 to infinity area. Then we get this area, this shared area. So 0 to infinity area is 1 by 2. That is half of the total area. That is 1 by 2 minus between 0 to 1. What about 0 to 1 area? So we know that P of -1 less than z less than 1 area is 68.26% or 0.6826. It implies P of 0 less than z less than 1. This area is half of this area, 0.6826 by 2. So that is equal to, get the 0.3413. 0.3413. So we know this area. This is a standard area, -1 to +1. So we require 0 to 1 area. 0 to 1 area means that is half of this area. So 0.3413. So that is equal to -0.3413. So simplify this one. That will give 0.1587. So finally we get 0.1587. So see here, for this problem, you have to convert this problem, that is a uniform distribution problem, into normal distribution, because all distributions finally tends to normal distribution only. All distributions finally tends to normal distribution. With only using uniform distribution, we cannot solve this problem. So we are converting this problem into normal distribution. First, we are applying the uniform distribution here. Applying uniform distribution, we are finding here mean value and variance value. After that, we applied properties here, properties of expectation, properties of variance. So applying the properties of expectation and variance, we are finding a mean and variance of this expression, x1 plus x2 minus x3. I'm taking that expression as u. So now, after this one, finding a mean and the variance of that expression, I'm converting that probability in terms of z, because to apply that normal distribution, we require z value. If you know z value, then only we will get the corresponding area. All these normal curves are given in z values only. So we have tabular values in z only. So that's why converting into z terms. We got z value -1. So that is equal to here z less than or equal to -1 is same as z greater than or equal to 1. So finally we got 0.1587. So this is the end of this problem.